So today's agenda, we're going to go over advanced nuclear energy. We're going to cover what it is, some of the use cases, types of fuel, regulations and policy, the Texas Advanced Nuclear Energy Office, and what is next for the state of Texas. Today we have some amazing speakers. We have Jarred Shaffer, who leads the Texas Advanced Nuclear Energy Office, the director. We also have Dr. Rusty Towell, professor and founding director at Abilene Christian University's Next Lab. So thank you guys for joining us today. I'll let you take it away.
Oh, maybe we can make this work.
Thanks for having us, everyone. My name is Jarred Shaffer, director of the Texas Advanced Nuclear Office. Prior to this, I was the governor's energy and electricity advisor, House State Affairs director, state senate for 2 sessions, did assistant clerk in the House. So very much have been in this room for lunch and learned a lot. And then you got it from here? And then
Hi, my name is Rusty Towell. I'm a professor of engineering and physics at Abilene Christian University. I'm the director of Next Lab. So if there are policy questions, Jarred's got us. I've been in this room once before. 2 years ago, I did an energy policy lunch and learn. So this is number 2 for me. I've not been here a lot. So policy questions, I think it's Jarred. If there's questions about the technology, the physics, the engineering behind advanced nuclear, I'm happy to handle those things.
yeah, that's definitely not Jarred.
Well, it's definitely not Rusty for the policy, right? So I think we make a great team up here because we have well-defined areas of expertise. These were readings you did. We'll pause here. Do you have any questions that you want to start with? It's going to be more fun if there's questions. I'll just say that.
I saw that there's been a pause on the nuclear waste facility. Is that still on pause at Yucca Mountain?
Oh, okay. So when you said nuclear waste, I was thinking about waste control specialist in West Texas that's in Texas, which has had a variety of different things doing and worthy of a tour if you want to know more about it. Yucca Mountain, so the commercial reactors, the 100 that are working in the country, their waste is the responsibility of the federal government. Long ago, when we stood up nuclear power in this country, the federal government says, we've got this. Your long-term waste, we don't want you being responsible for it and you going out of business and us having a problem. So the federal government raised their hand and said, we'll handle it. You're going to pay us. And so there's, I forget how many billions of dollars in this fund to take care of it, but we're going to take care of it, the federal government. It's not your job. So every one of those nuclear power plants still today stores their waste on site, and the federal government hadn't got their act together. Professor Rusty can say the federal government hadn't solved that. They said they were going to do Yucca Mountain. They started building it. People didn't like it. You know, no one likes it when someone says, we're going to put our nuclear waste in your backyard, right? All of a sudden that people don't like that. And so there's been problems there. The government is now having a more of who would like it? Who would like to have this industry in their backyard? And people are raising their hands for it. It's a different take, but we don't have a final resting place for nuclear waste, but I'll tell you there's a better solution than burying it anyhow. Great question, thank you. All right, oops, this is where we were supposed to introduce ourselves, or did I go backwards? I probably went backwards. How about that? I'll go forward. What's advanced about this nuclear? Oh, I can read.
It got me too.
All right. So there's 2 types of nuclear, fission and fusion. So real quick, fission is when we take something large and break it apart. So a neutron-induced fission, neutron hits a nucleus, breaks it into 2 smaller fission fragments, more neutrons, those go on and repeat the process. It's a chain reaction, energy comes out, heat. Fusion is take 2 little things, stick them together, and you produce heat, and that heat then is used. So both of these are involving the strong force. If you remember back to your high school physics, there's 4 fundamental forces: gravity, electromagnetism, strong and weak nuclear force.
Oh, I'm sorry.
Strong force is really, really cool because it's 1,000,000 times more energy dense than the others. So that means we need 1,000,000 times less fuel to get the same energy out. But the challenges is that it comes with some unique challenges that we're probably all aware of. But these are the 2 flavors. Every commercial nuclear power plant in the world is the fission process. The fusion process happens in the core of stars, all right? That's where it's happening. There's some small lab things that are happening there in the future. It's going to be awesome. What is deployed today is fission. And by future, I should probably let the vendor give you their opinion. All right. This is a slide from Tomahawk Energy,
You guys want to talk about
Tomac
it?
Energy. Sorry, I don't know who I just offended. Sorry. Oh, you're recording. That gets worse. All right. Well, you put little things together bigger, and you get energy out. It's exciting. It has lots of the same advantages as fission. Okay, but this technology has never been deployed commercially. That's their challenge, and they'll tell us how they're going to do that. What the rest of the talk is going to be about today is about what is commercially viable and what advanced fission reactors are about. So that's where we're headed rest of my talk. And so what is advanced fission nuclear reactor? Well, it's this neutron chain reaction we're talking about. It keeps basically, when we talk about advanced, I just want to say, when someone says advanced, if we have currently 100 nuclear power plants, commercial nuclear power plants in the country, what does it mean to be advanced? Well, it means we keep everything we like about nuclear power, right? It's safe, it's clean, it's reliable, it's energy dense, but we can make it better on all those, right? We can actually make some technology choices that make it safer, cleaner. It's multifunctional. It doesn't just produce electricity, but also produces medical isotopes, high process heat to desalinate water, produce synthetic fuels, and do so many more things. It's more efficient. We literally get more electricity out of the same thermal energy. It's scalable, so we can make this technology small. We can make it huge, and anywhere in between what you want, depending upon the technology choices and the fuel choices. We can use fresh uranium, we can use thorium, but we can also use spent nuclear fuel. So let me go back to the question of what are we doing with that, 100 reactors, the last 50 years have been operating, and all of their nuclear waste is sitting there. Where do we bury it? How about we not bury it and try to keep it safe for 100,000 years? Why don't we actually use that fuel to power advanced reactors, which we can. And so that's even a better solution. So I hope Yucca Mountain never comes online, because I hope we don't bury it. I hope we actually use it. That's a much better choice. And so that's what an advanced reactor is.
Same thing. Yeah. Passive safety systems are this inherent new safety feature that these reactors have. You'll hear walk away safe. Really, when you think about Chernobyl, you think about Fukushima, you think about 3 Mile Island, one common thread in those accidents is the human operator. And these systems remove in large part that from the emergency plan. And the system itself takes care of itself. The reactors are designed in a way where if the heat goes up, the reaction slows down, or inverse or something.
Nope, that's exactly right? If it starts to get too hot, it automatically shuts down that chain reaction, right? And that is at the core of what was missing from Chernobyl, if you want to go back to the core of it, right?
Right.
If power went up there, if the temperature went up there, the power went up, which is awkward, right? Because then the temperature goes up and then the power goes up and you spiral out of control. If you have the opposite, when temperature goes up, the power goes down, that's nice.
And isn't it what's happening too? It's the fission reaction is speeding up. So and what's kind of funny, what I found interesting is as the fission speeds up, less nuclear power is created, right? So you need to moderate these neutrons and slow them down in some of these reactors in order to facilitate the chain reaction. And what we're talking about in these safety situations, that will do it on its own.
Yeah, that's right. Walk away safe, literally, as long as gravity does its job, you can walk away and the physics shuts the reactor down. Does not require any backup safety systems, powers, operators, etc. The reactor is designed to shut itself down.
That's right. We're good here, I guess.
Lots of good advantages. We can keep talking for much longer than we have time. So a lot of times when you hear about advanced reactors, they break it up in different classifications, and I just want you to be aware of what those classifications are. So we have a molten salt, which is the reactor we're building at Abilene Christian University. It uses molten salt as the coolant, right? And what do I mean by coolant? Where the thermal energy is produced in the core, how do we take that thermal energy from there to where we want to use it? Whether that's a steam generator, turbine generator, or a high process heat or whatever. How do we move thermal energy from point A to point B? That's the coolant job. And if we use water, we have challenges, and that's older technology. That's the 100 commercial reactors we have now is using water. If we use a different coolant, we can make them safe. And so most advanced reactors just pick a different coolant and we label them. So When you talk to Zeta, Joule, trying to get this right, they're going to talk high temperature gas. That's their coolant. When we're talking what we're building at ACU with molten salt, other people use liquid metals or sodium cooled, and you'll hear other things out there. But that's just a different coolant running around your reactor. Lots of variations, reactor size and type.
Yeah, so I'm going to say this, and then Rusty's going to argue against me. These are just the basic kind of nomenclature: micro, modular, large, just to give you a sense of scale. And then their attributes. The talking point: one fits on the back of a truck, one is factory built, and then you send all the modulars to the site, and then the other one is Comanche Peak, STP, large construction projects. These are generally the accepted megawatt ranges, but like everything, there's, the details are not as or there's ambiguity here. It's not as black and white as it is. Did you want to go into
There's
why,
different types.
Yeah.
What?
Why that these numbers aren't necessarily.
Oh, let me go forward a few slides and
Okay.
I'll hit that. So when you're doing choice of coolant, and I already talked through some of this, you can basically, if you want to think about the world as being high and low pressure and high and low temperature, do we prefer a system to operate at low or high pressure? Why?
Not as likely to blow up.
Okay. So low pressure, less likely to blow up, so safer. What were you gonna say? Yeah. So pressure-wise, a low pressure system, if it's a leak, it's less danger. So pressure-wise, we would like it. And if it's less dangerous, that means we have to have fewer safety systems, so it's actually also cheaper. Also cleaner if you don't have to have a crazy big concrete and steel containment dome. That also means less capital up front and less environmental impact. What about temperature? Do we prefer high or low temperature? This is the one that your gut's going to get you in the wrong direction. Low temperature is safer, but low temperature doesn't allow us to do things that we want. There's a lot of processes and a lot of refining or industrial processes that don't kick on until you get to higher temperature. And also, if you happen to be trained as as an engineer, the Carnot cycle that says if you want to take thermal energy and convert it into electricity, then the laws of entropy say the higher temperature you start with, the more efficient you are there, right? So pressure, your gut gets right. Temperature gives you exactly wrong. We actually like high temperature because that allows us to be more efficient and also opens up these industrial processes. Imagine a foundry that needs to melt metal. Metal doesn't melt until you get to a certain temperature. So it's not just how much thermal energy you have, but it has to be a high temperature. And there's lots of processes that need that high temperature to get you over that threshold. So where are we on this? Well, currently all of our reactors are water. So we're in the exact wrong corner, right? They're low temperature and high pressure. So that means it's expensive and unsafe. And we can talk about these other technologies, and I'm going to let Zeta Joule talk about their gas, but I'll just jump us to this corner. It says molten salt is kind of cool because it allows you to operate at both low pressure and high temperature. And that's kind of a unique point that pushes us there. So what is small modular? SMRs or small modular reactors. So that's that middle category that Jarred introduced between micro and large. The small modular is lots and lots in the news about it. Robert Bryce, I don't know if you're familiar with him, is an energy author. He lives here in Austin. If you're not familiar with him and energy is important to you, I would encourage you to read his stuff because he collects lots of data and information. I'm not trying to promote him, but he's got good information, so I am promoting him. He has a list of small modular reactors, and so he tries. There's so many new developers coming out all the time. He has a list of them, so if you want to go look up and find about them, he's got a database full of them you can check out. Let me start with what's not a small modular reactor. So this is the last nuclear power plant that was built in the U.S. commercial size. This is the Vogtle reactor in Georgia. It took 15 years to build, about 9,000 people on site building it. It was over a $30 billion project. There was nothing small or modular about it. The pressure vessel alone was more massive than the Statue of Liberty. And it was so big, it couldn't be built in the US. We don't have foundries for that, so it was made in Korea, and it was shipped by rail to the US. So it came over on a boat and then a big rail, and the big shipping, or should be the big rail cart, actually came off the rails. It was too big for it, right? And so I would say this reactor does not have modules, right? And it's nothing small about it. If you did your reading, there's another company out there called NuScale that says, hey, we're a small modular reactor. And I would say if your modules come on a truck that looks like that, I'm not sure you're small modular. So I would define small modular as your parts are built in a factory. They move on a truck down the highway like normal things, not by special, whatever that is, 85-wheel trucks or whatever it is. I mean, so that's my definition. I don't care what power you are. I care about how the parts move down the road. But if you're writing policy, you have to have numbers. And so that's really not a disagreement, but we're trying to find conflict here. Small modular reactors are made of factory-built modules that can be transported and assembled on site. So that gives us the Henry Ford advantage of the low cost, the high quality, faster production, standardized, license at once, build it many times. So if you need an analogy, these are small modules that are built in a factory. They can be moved on site and assembled on site by a child. And so this is the concept of small modular reactor. And what is really exciting about it is not that you can actually pull it off once, right? But you can start replicating it over and over again, and we can actually start addressing the world's needs. So that's the cool thing about sort of small modular reactor.
Perfect.
Status in Texas in the industry.
Yeah, so just kind of the state of play here in Texas as it is, and we'll set aside all the activity that's going on the advanced side. So obviously we've got Comanche Peak, South Texas, Pantex. I don't know if it's on y'all's radar, but that's where they assemble and decommission nuclear weapons. It's up in the Panhandle. Waste control specialists was mentioned earlier. They have the ability to handle and store low-level radioactive waste, and there's some classifications in there. And then A&M, Austin, and Abilene Christian soon all have research reactors. Which research reactors are really great because they're the ones, generally speaking, are the ones that are making your medical isotopes. Which is the University of Texas, their pickle reactor, they'll ship them to Houston for MD Anderson or wherever. And that's like a real relationship and a real value, because what happens with medical isotopes is you really got to get them there quickly. So distance matters. And these research reactors really provide value to our medical industry here in Texas.
Bossy.
All right. So how did we get to here, or what's going on? The 87th did Senate Bill 7, and that really talked about what we're going to do with the waste and how we're going to handle it. It was revised last session. Basically, the answer is it's going to stay where you made it. That's the state's policy right now. There's a lot of conversations at the federal level trying to look at what's called the back end of the fuel cycle. Rusty talked about it earlier and alluded to reprocessing. We can get into it later. 1535, great piece of legislation, Senator Zaffarini. Workforce Commission's in charge of figuring out an advanced nuclear industry curriculum. TEA, Higher Education Coordinating Board. This is really how we make nuclear happen here. It's workforce development. And then obviously House Bill 14 created us, got me a new job, created the Texas Advanced Nuclear Development Fund. House Bill 500, the supplemental put $350 million into that fund, making it the largest state investment of its kind for advanced nuclear in the country.
In research. So this is the lab I get the honor of leading, next lab at Abilene Christian University. It stands for Nuclear Energy Experimental Testing. And our mission is to provide global solutions to the world's need of energy, water, and medical isotopes by advancing the technology of molten salt reactors while educating future leaders in nuclear science and engineering. Let me unpack that just a little bit. We love having a mission that's bigger than us, and we love the idea of taking a technology and blessing the world with it. Texas is the world energy leader. In the past, I think we've been blessed because we've had resources underground. In the future, the future is advanced nuclear, and that's going to be more like the automotive industry. Where are we going to build that, right? And Detroit, became Motown generations ago. can Texas capture the advanced nuclear business, right? If we're building small modular reactors, do we have the companies, the infrastructure here to do that and the supply chain around that? And do we have the workforce next to that? And the bottom line there, educating future leaders in nuclear science and engineering. So we have a mission of blessing the world. We know the value of energy. We know the value of high process heat, especially as we think about cleaning water. So water and energy, a lot of people argue which of those is more important until you get cancer and you need those medical isotopes. And then all of a sudden that becomes the most important thing. But the ability to produce medical isotopes, these are life-saving isotopes that are produced where? In the whole universe, you find these things in two spots, in the core of stars and the core of nuclear power plants, because that's where the nucleus changes and you produce these radioisotopes. And they have lifetimes of hours or days. And so you have to get them from where they're produced and into doctors' hands in a very, very short amount of time. And we don't have the technology to grab it from the core of the sun and bring it here. We don't even have the technology to grab it from the core of Comanche Peak or South Texas and get it in their hands because pressurized water reactors with solid fuel do not allow us to do that. But if we have molten salt with liquid fuel technology, we can do that. And so our technology choice here of the molten salt reactors allows us to do that. It's an exciting mission. Thankful for it. I'll keep moving. Where are we at? Well, we have a permission to actually build this reactor. And so the Nuclear Regulatory Commission is the federal regulatory body, and they have never before given out a license for a liquid-fueled molten salt-cooled reactor until they approved our application in September of 2024. They were so excited about it, they gave us all these little pins. So I'm not a legislator. Some people see this pin and start give me very nice treatment as I'm walking to the Capitol. I'm not a legislator, but the Nuclear Regulatory Commission did give us this pin that said we issued Abilene Christian University a construction permit. They were as excited as we were for this historic event. We do lots of research on campus. We work with a lot of different salt systems and chemistry, all sorts of tools, but all of it is pointing towards building the molten salt research reactor on campus, that advanced reactor. So we are partnering with the University of Texas and Texas A&M, and both of them have a research reactor on their campuses. We're excited about that. We've learned a lot from them, but they are solid-fueled, water-cooled, Trigga, off-the-shelf, 60-year-old technology. Literally, Texas A&M reactor, I think, has been operating for over 60 years, right? It's an amazing reactor. It does great things. We can have an advanced reactor. It's time for our technology to advance. I mean, just imagine if you were using a phone or driving a car from 60 years ago. Why on earth is our nuclear in the state of Texas 60-year-old technology? We have a facility on the Abilene Christian University campus, which we refer to as the Dillard Science Engineering Research Center. It's the only advanced reactor test facility in the U.S. I think 2 weeks ago, Idaho National Lab brought online a dome, which is a test facility. So they have joined us. We were the first. Now there's another facility. This is the first outside of a national lab. But what's really special is this trench that's 80 feet long, 25 feet deep, where you can deploy a small modular reactor, put a concrete box around it, and allow us to prototype, test, collect data off of advanced reactor. You're welcome to come tour this facility. Would love for you or your office to come and see this. I think the Powerhouse Texas is organizing a trip in a couple weeks. So if you're not planning on coming with them, let me know and we'll set up your own trip, but you should come with them. Did I say that right?
That was perfect.
Great. Recent federal highlights for this program from the federal government is the federal government's allocated 500 kilograms of fuel for us. They picked us to be part of that executive order on pilot program, and they've awarded us some coolant salt. So literally the fuel and the salt that's going in this reactor are recycled from old reactors at Idaho National Lab and Oak Ridge National Lab that were there. So the technology we're talking about here is not something that's questionable. They actually built one of these reactors in the 60s at Oak Ridge National Laboratory. We're thankful for that. State of Texas committed $120 million to this project in partnership with Texas Tech and the Texas Produced Water Consortium. Again, this idea of how do you produce electricity and purify water and how are we better together. A summary of our project on the ACU campus is the Natura Resources. That's the industry that's sponsoring this project and developing it. They formed this research alliance with the University of Texas, Texas A&M, ACU, and Georgia Tech. If you wonder why Georgia Tech made it in there, it's because they stole the director from the UT research reactor. And so we wanted him on the project, so Georgia Tech is on our team. But that research consortium has submitted this construction permit. We're the first person to get it from the Nuclear Regulatory Commission. We built this building to house the reactor. We're on the path to be the first operating advanced reactor in the U.S. On the path, there's other people competing and working hard. That's great. Natura is positioned to be one of the first commercial reactor vendors capable of deployment. How do I pronounce it?
Yeah, this is the biggest question in the nuclear space right now. It's TANEO. When we were doing House Bill 14, we didn't really think about the acronym, so there's a lot of confusion. So. All right, how did we get here? And I know a lot of you guys already know this story, but in August 2023, Governor Abbott sent a directive to the PUC to formulate the Advanced Nuclear Reactor Energy Working Group, which they also didn't think about their acronym either. Led by Commissioner Gottfelty over the course of about a year and a half, they really brought together industry, the public, academia, and really looked into this issue of how can Texas get in this game? How can Texas lead in this emerging nuclear renaissance? So that report was delivered to the governor prior to last session, and really became the basis in large part of House Bill 14. Some of the recommendations they had identified were incorporated in House Bill 14. And really what was the true value of the working group is, as y'all know, you work really hard during the session. If you don't get something over the finish line, maybe it's an interim charge, maybe not, we'll try next session. This working group really allowed us to create and maintain momentum going into last session. I think you guys probably felt that in whenever House Bill 14 might have come on your radars. It had a lot of support. The nuclear conversation had a lot of support in a way that it hadn't in, at least in my time here in the ledge. What does House Bill 14 do other than give me a job? Representative Cody Harris and Senator Charles Schwartner established our office, so we're housed within the office of the governor. And really what our focus is on, every state is doing it differently, and it's all good and great, and I love that we're all competing. I want Texas to win. So every state's kind of doing it differently, but our focus is really supporting the development and commercialization of the advanced nuclear industry, right? So as he's talking about, this industry's still trying to get to a mature form, right? And we want, through our grant program, through our office, to help support that development and have that development and commercialization be here in Texas. How are we going to do that? We've got a $350 million fund, like I said, the largest in the nation. 3 programs, mostly just going to talk about 2. One's not funded. So 20% of that 350, so 70 million to the project development and supply chain reimbursement program, right? So this is you get up to 50% eligible reimbursement or $12.5 million, whichever is less. And it's for costs associated with site characterization, environmental review, licensing work, but also, and I think that where Texas can really lead and win in this space is increasing the manufacturing capacity. We have so much industrial capacity here, not only to develop the nuclear grade side of it, but encouraging existing players, may it be in the oil and gas industry, to pivot into this new business opportunity that is the equipment and component space for the nuclear reactor industry. The second program, and then also this one, fuel cycle development, right? So I didn't know until a couple years ago that Texas has 8% of the known uranium reserves in the United States. But the thing about uranium reserves is it's not necessarily concentrated in one specific, well, down in South Texas, it's really concentrated, and we have a lot of uranium potential on the mining and milling side. And when you look at the United States, and we'll get into it a little later, the fuel side of this conversation is ripe for competition. So what we're looking at, and through our kind of strategic portfolio, is what can we help support that accelerates Texas's strengths, and what areas are ripe for competition, right? So that's kind of a guiding light in what we're looking at. So the second program is the Advanced Nuclear Construction Reimbursement Program. Same kind of deal, up to $120 million. We're talking reactors and fuel cycle facilities. So an enrichment facility or well, Natura is not eligible. Xanadu, because they already got their 120 for their program. And then the final one, basically, it's unfunded, but this is the legislature thinking forward and like, how can we encourage nuclear electrons to get onto the grid? Once this gets funded, our office and the PUC will get together and by rule, we'll establish a $1 per megawatt threshold grant. So it's really just trying to encourage overbuild or arrangements where the customer is willing to energy arbitrage, right? So if I keep saying the example, Dow and X Energy, their project, Dow needs 300, X Energy builds 350, that 50 goes onto the grid. This program will provide an additional revenue source for that project financing. So that's really cool, but it's unfunded, and like all of this, it's happening now. It's insane what's happening right now, but we also need time, right? So it's both can be true at once. We are responsible for a biennial strategic plan due to the ledge, like most agencies. And we're really we want to create a policy document that focuses on the ecosystem, right? Because we're talking about reactors, but it's really the supply chain and the manufacturing and the workforce. It's the whole ecosystem that we want to develop here. And we're gonna look at these areas here through our strategic plan, and we're gonna have this long-term vision of we want the commercial industry here in Texas of the ecosystem. Here's a short-term action plan you guys can do next session. Or here's things to think about going forward. Here's some challenges. This has changed. This is a way for Texas to take advantage of that opportunity. So that's the kind of stuff we're going to be looking at. We want to provide value in an action plan to really continue and accelerate moving forward. And then finally, the nuclear permitting coordinator responsibility, basically just a one-stop shop for a project developer. I can get you connected to wastewater division permitting people. I can get you to the historical commission. Depending on the project type, everybody's got a different state regulatory pathway and permitting scheme. And you can come to us and we can help facilitate and accelerate you through the regulatory process. We are for sure not a regulatory agency. We're just here to help. And then go next. More or less, we're not a workforce development grant program, but everything that we're trying to think about is how can we use this as an opportunity to develop Texans to work in this future industry that I know is coming. Again, nuclear permitting coordinator. Here's a couple of the agencies that are involved. Again, a one-stop shop. We are, at Texas with the NRC, we're what's called an agreement state. So there's certain regulatory authorities that the NRC has, in a sense, delegated to us, and that's really DISH's. So they do the radiation control programs for the state. So if you've got medical nuclear grade equipment, you got to get a license. If you're in the oil and gas industry and you're using some equipment, some of it's radioactive, you got to go get a license. So DISH's is that point there. Right, yeah. So a little bit more about, it's really just to support the initial development of what we're classifying as an advanced nuclear project. And it's all these things, right? These are eligible reimbursement expenses up to the 12.5 million. You've got NRC licensing, you got site environmental characterization, really keen on trying to reinforce the manufacturing development. And then the fuel cycle is ripe for competition.
Question.
Please.
Are the grants open to all different sizes of the advanced nuclear reactors?
Yeah, so the way we're looking at, we have some eligibility requirements and they're pretty basic. Pretty much anybody can apply. But you have had to show that you've got skin in the game. Your own private capital has to be expended in your project before you're even eligible to talk to us. Remind me your question. I got lost.
If the grants are open for all the micro, the modular.
So what we're assessing, and again, we're not the expert, and it's not our job to pick winners and losers on reactor type, technology design, size of the megawatt. What we're assessing in these programs is how likely is this project to be completed, right? Like, so that's what we're evaluating, right? We don't have the skill set to be like, well, that coolant and this and that pipe and this system, we just don't have that. But like all things considered, which of these is going to get completed? And which of these brings the most benefit to the people of Texas.
Could you speak a bit more about the permitting piece? I didn't quite understand your role versus like the federal regulators, like how that interplays.
Yeah, so it is an agreement state to the NRC. It's basically like what we just did with Class 6 wells with the EPA. They delegated authority to the Railroad Commission to have oversight. Same kind of concept. The NRC says, hey, when it comes to licensing radiation materials, dishes can do that. We're not talking reactors, we're not talking fuel, we're talking medical equipment, or I think the health physicists have to
Yep.
even get, you can only get so much radiation a year, and depending on your profession, sometimes you get a little bit more. All of that stuff, those documents and numbers they turn into a test, they turn it into dishes, right? So like dishes
What's
plays that
dish?
role.
Can you say dish?
Department of State Health Services.
Right. Thank you.
Yeah.
Sorry.
So it's just this
Everyone here
limited
knows that
point
movie.
of this nuclear conversation that they've said, okay, on the radiation control side, here, state of Texas as an agreement state, you guys can take care of that. We're going to maintain oversight of safety and security of the reactors, the fuel facilities. They still got to go get licensed by the NRC. But when it comes to licensing him in order to do a thing, dishes can do that.
So at ACU, let me just add on. I'll get you. At ACU, we have a license from the state of Texas for research-sized radioactive sources. So in our labs, we're working with research from the state of Texas, delegated authority from the NRC. When we get our reactor, we can't go to the state of Texas and license our reactor. We have to go to the federal government, to the Nuclear Regulatory Commission, and that's the only agency that can give us permission to build or operate the reactor.
So it's like radioactive material side is what dishes has been able to license on their own. Some states have the NRC do it.
So policy lens, when we're talking about, we talked about how maybe a commercial entity or industrial entity might develop one of these projects to power their facility, and maybe they overproduce so that they can dump some back onto the grid. When we think about policy, statute, rulemaking, whatever it is, contractual agreements with these, what do we need to consider for future safety concerns, weather related, et cetera, energy needs, another URI type thing? Because if they build it, they own it, they put the cost and everything into it, and they need it for their facility, they're going to want to power their facility. What safeguards do we need to think about to make sure that local hospitals or residential areas or other critical infrastructure is still going to be okay in an event like that?
Yeah, and I think, and maybe we can tag team this one, but I think in large part also it's these systems are different, right? And so like what has historically been the licensing pathway, it's always been for one of these big ones, right? And so what the NRC is doing now and saying, okay, you don't need a 10-mile security perimeter for a 50 megawatt reactor, right? So that is changing at the federal level. I think for now, it's appropriate for that safety case to maintain where the expertise lies at the NRC, right? So I don't foresee our role in the state growing in regards to like oversight over safety and environmental hazards potential, right? So like all of that analysis of, can this reactor withstand an earthquake? Can it hit a hurricane? All of that resides at the licensing level at the NRC. And it will change given there's new regulatory pathways, but it'll still be maintained and the oversight will be retained by the NRC.
My question, I didn't explain it well. I wasn't concerned about the safety of the facility, but more, is there anything we need to consider from a legislative policy making or regulatory policy contractually so that we're not facilities aren't relying on the excess power from there in the event that power is lost throughout the rest of the grid, and now all of a sudden they're like, oh no, we don't have the power, and the generating facility's like, sorry, too bad, we've got to have it. Maybe is there a threshold thing? But
yeah, no, that's a good question. I don't have a great answer for it. I think that what you're seeing with Senate Bill 6 this past session is kind of that conversation, but just for existing generation resources, right? This idea of net metering maybe is kind of what we're talking about here. I don't have a good answer for you. I don't know if the state's role is to get into bilateral contracts and start meddling around in those arrangements, but I guess I just don't know a good answer. I don't.
Yeah. I mean, this is definitely a policy question of, if I'm selling 50 gigawatts excess from my private behind the meter onto the grid, what assurances that it's there in a need of emergency? That's a policy, or I mean, it feels like that's the R in ERCOT, but
But it's also don't take into account. Don't forget that like the capital investment and the risk associated with building this thing and having the be able to put on it lies with the project owner and how they project financed it. So again, kind of going to this Dow and X Energy, they are equity stakeholders in this project. And it's not the state's like role to get inside and say, hey, Dow, whenever we're really in trouble, this $1 billion you put into it, you can't have it, right? Like, so if that kind of arrangement, I don't foresee happening in the future. But yeah, I just don't know what will happen in the future. But those bilateral contracts, I think it's not the state's job to get into those kind of arrangements. I don't know. Maybe I'm misunderstanding the question.
no, I think it's a tough question.
Yeah,
but
that's the thing. But there's so much happening right now, and it is happening right now. But we also need time to figure out how this is going to look once it's matured in a viable, resource on the ERCOT market, or pick it off the shelf and you can go use it for your hyperscaler. Like, it's going to take time, not that long, but I don't have the answer to some of these questions when it's all figured out.
Sorry, I have another one, but you just gave me a good segue. So you're saying that we could use this for a hyperscaler. I've heard some data center developers making what I would classify as somewhat absurd claims that, like, oh yeah, I'm just going to plop down a small modular reactor for my data center, and they're saying it as if it's like almost like a done deal, and that to me seems kind of to be an exaggeration. I mean, how would you characterize that?
I share that skepticism. I think having a healthy skepticism in this entire conversation is a good thing to have, right? Because there's a lot going on, and there's a lot of excitement, and there's a lot of people excited. So when I hear that, I love that idea and that future possibility. What I'm curious is this idea. It also depends on the load profile, right? Like, are we talking about somebody that needs to be on 50%, 100% of the time, or is it like an inference, or is it something other where they can load, they could ramp up and down? That ramping up and down, these small advanced reactors are absolutely going to be able to load follow way better than any of our traditional nuclear assets. But that demonstration, I have yet to. There's no commercial application there that has said this can actually happen. But I do think that these technologies can make that happen, right?
But they would also need federal approval for each site, correct?
So that's what's happening, and we're going to get into it. What's happening at the NRC regulatory licensing wise is wild. Like, historically, the biggest impediment, at least if I've heard, is the morass at the NRC. They basically just kill projects through analysis. That is no longer the case. So they're creating new licensing pathways for these new advanced reactors, right? Because historically, it's just been one big project, right? And so you've got basically two pathways to do it. You could either start your construction and then start moving dirt, build all the figure it out, get licensed for that piece, and then come in and say, hey, now I want to operate it. And then they give you an operating license. So it's a two-part process. Or you can come in and say, hey, I want both at the same time, right? Those have traditionally been the two pathways. But that model doesn't really work if you're going to do microreactors. You want to deploy that, hundreds across the country, right? So what the NRC is doing is reforming or creating new regulatory pathways to market, and called Part 53 and Part 57. And it's just basically, it's essentially that. They'll say, hey, this makes sense. This design is safe. We approve it. And then they'll just basically come before the NRC and say, okay, now we want to do it in Idaho. And now we want to do it in Texas. And so it'll be much quicker from that standpoint.
And let me just add a thing here, because I think this is an opportunity for Texas. Exactly. And so if there's anyone in the room that has the ability to influence policy in the state of Texas, let me float this thought. If we go back to the small modular reactor, where we're not building, great, we've built 100 commercial reactors over the last 60 years. That's the old pace the NRC worked at. If we're doing small modular reactors where we have a factory and every day a reactor comes off that factory, then we're not talking about, over the last 30 years, the NRC has licensed 3 new reactors type of pace. We're talking about a pace where every day they need to license a new reactor. Well, if that reactor is identical to the one they did yesterday, you don't have to ask the question, is it safe again? You can still inspect for quality, but you don't have to re-examine the design. Then what's the difference between reactor, the first one, the second one, or not the first and second, but the 300th and 301st reactor? Well, where are you putting it? And so could, the same way the state of Texas get delegated authority to license research quantities of reactor material or to drill a well from EPA, could the state of Texas get delegated authority from NRC to do the site-specific work? Texas probably knows more about our sites than DC does anyhow. So if we're going to add a 4th small modular reactor right next to where we have 3 of them already deployed in the Permian Basin to desalinate that produced water, and it's the exact same design, maybe the NRC just rubber stamps it, and the state of Texas comes in and says, if we add a 4th one there, does it add a new hazard? Is it in a place where there's fault lines, et cetera, et cetera? As long as it stays in this environmental conditions, Texas could do the site-specific work. And somehow we have to speed up the regulatory process, right? It can't take, for us, it took 2 years for them to review our application, 15,000 man hours. If we want to make a second one just like that, it should not take another 15,000 hours. It should be very short, and maybe the state of Texas does its own delegated authority to do that. That's something that I'll float that to you.
No, I could foresee that future for sure. Yeah, and kind of just to piggyback off that, then it becomes, rather than the existing licensure pathway at the NRC in this model, all the NRC is doing is saying, okay, that design that we know is safe, does it work with this environment at that site, right? So it speeds up that process. And so the company only has to go to the NRC and say, I'm telling you, this site works. What do you think? And then they're like, okay, that site works. Go and do it.
All right, we're going to keep moving. I went backwards. How about go forward?
Yeah, and then the advanced nuclear construction one up to 120. Key piece of this one, in order to be eligible, you have to have a license application or permit application docketed at the NRC. So there's certain steps to the issuance of a license or a permit. You start talking to the NRC, you say, hey, here's my application. They'll look at it, and if it looks complete enough and worthy of their time, then they'll assign a docket number, and then they'll docket you. So what the legislature, I believe in doing this is it's a validation of credibility threshold, right? You're not eligible if you just have a really good PowerPoint, right? Like that's what this is really trying to get after. And some of those reimbursable expenses are anything to do with your licensing work at the NRC, the procurement and development of long lead time components, and then just construction related activities to the project.
A question. So how do your office generate revenue for the state?
So we just have the $350 million fund, right? So how do we generate revenue? At the end of the day, this is an economic development and a workforce development opportunity, right? Like in pursuit of this commercialization of this industry. And so how do we get an ROI? It's by being successful. They need suppliers. They would love those suppliers to be here in Texas. How can our office, with our $350 million, crank up their output so they can go and start doing nth of a kind and build however many a year, right? So the economic development opportunity is tremendous and probably really hard to quantify. But one way that we've kind of, our guiding light is this is the Texas tax, this is Texas's money, Texas's people's money. How can we create the biggest benefit to the people of Texas while also doing this really cool thing here with nuclear? And so what we've done in the way that we're going to evaluate and look at applications is if 2 applications are even, apples to apples, but one has a clear commitment to the community, to workforce development, they've gone above and beyond, they've gone, sponsored STEM programs at a K through, whatever it may be, we're going to take this project over that one, right? If all things be equal and one is demonstrated, we're serious about building this up here in Texas, that's what we're going to build into our scoring rubrics.
We have less than 10 minutes, so let's go ahead and move on to part 3.
Perfect. Well, that one we'll talk about in a couple years. Basically all the stuff we've just been talking about. That's us. Okay, and we've kind of alluded to it, so
Yep,
we can
we've-
just skim through it.
We've talked through a lot of this, but
This is a great slide, right? So like, where's the delegation of federal role versus state? Can't get it all, but we'll keep going. Yeah. So generally, this. Like I said, we're an agreement state. These are our lead agencies, more or less, for nuclear-related activities. Keep going. I want to get to this, but I think I have another. Yeah, okay. So the Atomic Energy Act is really what created the NRC. It's the governing act of the nuclear agency. In 2024, they created the Advanced Act, or passed the Advanced Act, really just told the NRC, hey, reform, get better, cut your licensing fees. And then in May of last year, the Trump administration put out 4 nuclear executive orders, and that's what I'm most excited to tell the legislature and you guys about, is how much that has changed the game, right? And so one is about overhauling the NRC. The NRC now is saying, and they're proving it, you can get a license in 18 months, which is insane, right? And they've cut their licensing fees in a lot of respects by half. Next one's about deploying nuclear on military bases. So the Army has this program called Project Janus. They selected a bunch of military sites based off of their resiliency needs and how important that base is to operational military stuff. And Fort Hood's one of them, right? And so like, that's awesome that Fort Hood's being considered to be a participant. The Air Force just has a similar program for their needs. JBSA was just selected to be one. So like, things are happening in Texas. It's insane. Like the JBSA announcement happened 2 weeks ago. Like, things are happening here already, and it's super exciting. The next one is about supply chain and workforce, and then this third one is the really exciting one. It's about advanced reactors and creating a pilot program. So what the DOE did for the fuel facilities and the reactor facilities, they basically said, hey, we're going to give you a pathway here. You don't have to go to the NRC just yet. Come through us and demonstrate your project. Get all that information and data points and those safety cases. So then when you go over to the NRC, you can go faster, right? And so that's what Natura Resources is doing. And if you keep going.
can I just
Please.
say one thing? I don't want you to lose this second bullet point up here. It's a small little bullet point, but changing the mission of the NRC. The mission of the NRC used to be to make nuclear safe. And the safest anything, the safest car is what?
No car.
No car, or the car you never drive, right? So the safest reactor is the one you never approve. And so I think we had decades of the NRC fulfilling its mission to keep things safe by just stifling the industry. So this was huge when the mission changed from not just keep it safe, but also make sure you are efficient and doesn't limit the benefits of it. It's a technology that's going to bless the world. Let's not leave that off the table just because it could someday have a oops, right? I mean, yes, nothing is perfect and safe, but we can keep it safe. And also, when hundreds of Texans died during Winter Storm Uri, that's a real cost, right? If we had more nuclear power plants, we could have saved lives that week. All right, didn't want to miss that.
Yep, no, that's great.
Final thoughts.
I guess this is me. Yeah, so we're also conducting a study with the PUC that's due December 1. We basically got to kind of just scope out the regulatory process and permitting process for a nuclear reactor in the state. We're going to, through our strategic plan, kind of come up with some recommendations for you guys to consider going into next session. Again, workforce, supply chain, the fuel cycle is going to be really, these are ripe for Texas to win on. Yeah, and kind of going back just maybe a couple slides. Is that the end? Are we done after that?
I don't know.
Okay.
We got a few more.
Okay, well, let's keep going. Okay,
All right.
This is where I want to go then. Keep going. Okay, yeah, so this is just more of it. So this is the follow-up actions. What the NRC does, they now have like an 18-month issuance date. These are what I was talking about. Project Janus is the Army. We've got Fort Hood selected. The Advanced Nuclear Power for Installations, that's Air Force. JPSA is selected, which is really exciting. We've got the DOE Fuel Line Pilot Program, which is the same thing that these guys are doing, but for fuel cycle. So conversion, enrichment, fuel fabrication, not sure if any reprocessing in there. What's really interesting is they spoke to the Defense Production Act agreements to really accelerate our conversation on how do we make more fuel. And there's a lot of really exciting things going on in that space, but it's pretty closed lip. So more to come on that. But it's really, really cool. What the federal government's trying to do is really trying to make this happen, and they're attacking it in so many different ways. And it's super exciting, but it's also like, wait, what is actually going on right now? Because there's so much. Okay, next one. Yeah, so this is the one that is really exciting as well. And the point I want to make with this is how we're so in the game and so in the lead, and we are just getting started. Like naturally, we're already in the game, right? So there's this DOE reactor pilot program with this goal of achieving criticality July 4th. Basically, my dumbed down understanding, and Rusty, tell me if it's just sustaining the reaction. That's what criticality means, right? One neutron in, one neutron out.
Yep.
But we're not producing megawatts necessarily. So DOE says, okay, you come through our process, you'll get our technical expertise, you'll get land, you'll get resources, the help to get your demonstration project done. So what they're doing is they're demonstrating their project, and then they'll take those lessons learned from their reactor, and then they'll go and submit their commercial application to the NRC. And so Allo Atomics, Antares, Atomic Alchemy, Terrestrial, Natura Resources, Last Energy are either a Texas-based company or doing projects in Texas. Like of those 11, look how many have stars on them. And we're just getting started. Like this is why it's so exciting right now. This has changed in a year, right? Like this wasn't around when we were doing House Bill 14, moving them through the chambers. Like this wasn't even contemplated. And now it's about to happen, and then big milestones are gonna happen here in the next couple of months. And this is also a really great talking point that I take a lot of pride in is we're the only state to have a pilot program project, and we have multiple, that's not located at a DOE national lab, which is insane, right? Like the whole benefit of this program is the DOE assistance, and we're doing so well down here. We don't even have a national lab, and we've already got three projects in this program doing business down here. So it's really, really cool. And then we've kind of talked about it. The uses of high nuclear energy, grid, direct air capture, desal, blah, 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 blah. And then we can get into fuel cycle. We don't have to, but yeah, mining, milling, taking in South Texas, turning into yellow cake, conversion, you turn it into a gas, uranium hexafluoride, you enrich it to, historically it's been 5%, anything 5% and down, LEU, low assay.
Low enriched uranium.
Okay. 5 to 20, HALEU.
Let's transition into a Q&A period.
Perfect.
10 minutes.
I'm done with
All
that
right.
anyways.
Questions?
Perfect.
Yes, sir.
This might be a dumb question, but
I'll
just
take it. That's my forte. Thank you.
so, like for reference, let's just say we're in a Michael Bay movie and all the oil and gas disappears, okay, and all the solar gets blotted out. Our only hope to power the state of Texas is nuclear reactors. How many of the modular or the nuclears would it take just for scale? Like the ball, just because I don't know. I'm just.
No, great question. So we use about 80 gigawatts on a high day.
85's peak.
85's peak gigawatts. A big South Texas Comanche Peak, they produce about 1. So we'd need about 80 of those. Well, some of them produce 1.2 or whatever. So I'm a little bit low on my numbers, but on the order, we need 80 of those big ones. And so if a small modular reactor produces 100 megawatts, then we need 10 times more. So instead of 80, we need 800 of them. I mean, but if they all fit on the back of a truck, then again, it's not a huge thing. And that's the peak. I think if you pull out your ERCOT app, it's probably closer to on this cool day.
Probably the 60s,
In the
70s.
So wait,
60s or
you're
something.
saying that so with 80 of these devices that fit on the back of a truck, you say
800.
Eight.
And
800,
again,
my
I
bad.
mean,
Okay.
but it's 800 of them would power the whole state of Texas.
Okay, got it. Oh, that's
But there's also 80 of them that could power. There's 300. Like that's the thing about this space versus micro modular, and it's so customizable and configurable, right? So while there's how much do you guys put out?
So
Each
the
one's
reactor
different.
at the university, the research reactor, is going to be 1 megawatt, right? It's not going to be powering homes. It's just designed to study the technology. But Natura Resources, their envisioned first commercial reactor, the molten salt reactor 100, MSR 100, would be 100 megawatt electric.
Right. So that's the product. Whereas Zettajoule's product's like 300 megawatts plus, maybe 345.
The research is going to be 30. Eventually, it could go up to 600.
So it just kind of depends on which one we're buying. But yeah, what you need to make up for is about 80 gigawatts of electricity. And that's that, yeah.
Are there
Today.
plans to replace the older technology at A&M and UT?
Yeah, I mean, on the one hand,
Maybe.
yes and no. I'll speak out both sides of my mouth. The reactor there has a mission that's still useful and valuable, right? The producing the medical isotopes is still an important work. That reactor is a great neutron source, and so it has great training for people, and it does a mission. It does not test the technology that Zetajoule wants to deploy or Natura Resources wants to deploy. And so if you want to test that, you need different. Instead of a water-cooled reactor, we need a high-temperature gas or a molten salt-cooled reactor. And so we call it a research reactor at ACU. Natura refers to it as their demonstration reactor. They're demonstrating the technology, collecting the data they need to give to NRC to scale up to something 100 times bigger, which then goes to commercial.
And then so what we have today, right? Maybe that's all more of the question too. It's like what's up with Comanche Peak and STP? It's like when you think about it, they're not that old. They've been commercial authorization 89, 90, 91, right? So they're not old. And what's happening right now is you're seeing at the federal level, the NRC license, I believe, for a nuclear reactor is either 40 or 60 years, and 40. And what they're happening now, it's like they're not dead, they're still good, and they're paid off, right? So what's happening right now is you're seeing the NRC extend licenses further, right? So it's license extensions, like those assets aren't going anywhere anytime soon.
Yep.
And then there's also this idea of uprates, right? So Comanche Peak right now is 1,000 megawatts, for instance. They can do things, either the control systems, utilize their fuel well better. Some of these things, they're called uprates, and it can, increase their output of their megawatts. So they could go from 1,000 to 1,200, right? And so that's the real opportunity here in the state of Texas for our existing fleet is that uprate conversation. How can we get more out of what we have?
I'm not sure it's been stated, but Zetajoule does have an MOU to explore putting a research reactor at Texas A&M. And they presently have 2 very old ones, and so this would be the third.
And it's great, and it's not only has a value in what it creates to the medical industry, but again, going back to the workforce development, it's huge that the students can have this new testing reactor to play around with, to understand, because this is the future of the commercial market.
That's right. And I haven't said anything about the Rellis campus at A&M. They want to bring in reactors not just to do research on their reactors, but actually to build power to power the rest of the research center. As they bring in their own local supercomputing and things like that, they need energy needs there. And so there's multiple companies that are considering deploying a power producing reactor on the A&M campus to help that research facility move forward. So there's a group of folks that are a part of that too. Thank you. So I'm sorry, several hands. Yes, ma'am.
So we have Comanche Peak at the district, and this industry's done a really good job of interacting with the public.
Yeah.
Like, our constituents' only concern is whether or not they can fish on the pond next to the nuclear reactor. So can you talk about how you interacted with the public? Because there's several other industries that have not done a good job of explaining safety and how it's evolved over time.
No, thank you. That's a great question, and I think it's something that we've talked about this morning as before the session started. Is how do we talk and communicate to the public, to executives, to future generations about this, and ensure them of what's going on. And so, let me tell you about the story at ACU in Abilene, right? Because we have the facility built, and we have ready to drop a nuclear reactor in the middle of the city next to our campus, literally across the street from our brand new dorms, right? And so if you think about recruiting students to come to your university and say they're going to live there and the nuclear reactor is going there, this is walkaway safe technology, but you have to be ready to explain that and talk it through it, right? And so what have we done at ACU? We have communicated on campus and off campus and to our neighbors And anyone and everybody that asks a question, we bring them in to tour or we go out and talk to them. So I can't tell you how many times I've gone to Rotary clubs or Kiwanis clubs or the Tuesday morning Men's Methodist prayer breakfast and talk to them about this project. It just doesn't matter. If someone says, we're interested, I want to go and tell them, right? And you can raise fear in like a bumper sticker, right? But if you want to explain how this is walk away safe and literally it's safe, I can talk to you about the advantages of low pressure, right? And how that makes it so safe and how we're have a technology that as long as gravity does its job, we are safe. And I can explain the technology, but then I can also say, oh, and by the way, we had to submit this idea, before we had permission to start building it, we had to submit our plans to the NRC, and they spent 2 years, 15,000 man hours of 80 experts reviewing every aspect of this, not for does it work or is it commercially viable, but what they did for that 15,000 hours is it safe? Is it going to release radiation to people or the environment? That's all they asked. At the end of it, they said, this is safe. So I can explain the technology. You can look at what they've done before, but you have to communicate that out. So if you come to our building, our facility, you will see, unlike if you go to UT or A&M, and I'm not bashing them, but they were built at a time where those facilities, you can't step in the building at UT without pushing a button on the outside, right? You show up on the Pickle Research Campus and you walk up to the building that has the nuclear reactor, you push a button on the outside, and they don't let you in the building until they know who you are and they let you come in. ACU, we have a public lobby that tells why, right? This technology is safe. It was demonstrated in the 60s. We want to bless the world with the medical isotopes and the energy and the high process heat to desalinate water. And you can come up to the window and look through and see what's happening in the research bay. And so we are intentionally doing everything we can to be transparent because that's helpful. It takes a lot of time, energy, and effort, but part of where we, ideas back to the state is how can we communicate this? And again, how do we get young kids excited about the prospect of going into this field? They're certainly not going to do it if they think it's going to cause them to have cancer or it's dangerous. So it's a very important aspect of this whole industry to get a better reputation than it has in the past. I think in the past it was we don't want to be in the public view. We want to be forgotten about. That's really what they want. I think we have an exciting opportunity to tell people about us and not hide. So, great question. It's not. I don't know of a simple fix. I think it just takes a lot of effort. But when you go through that effort, people are receptive. So twice the city of Abilene has invested economic dollars into this program because of what it's doing.
Yeah, and I think from our perspective, like one of our key responsibility is public engagement and community engagement and really coming up with a public outreach strategy. And kind of like what was alluded to, it's definitely an art and it's not a science. But what it is it's a matter of putting it in the right correct place in project to-do list, right? So I think what you're seeing a lot of what's going on right now, it's that the community wasn't first. And the only way this is going to work is if community is number one, right? Because the story is incredible. The local development is tangible and real. You go down to South Texas Project and go to Bay City, you talk to the hotelers there, they're so excited every time the NRC comes in for an inspection because that's busy season, right? It ripples through the community. And we've just got to take best practices and then our office, because every place is going to be different depending on the project size, the community they're in, and it'll be our job to help facilitate that community engagement on the front end, either it be getting with y'all's bosses or you guys and being a resource as you guys field constituency calls or hosting events at the local level, getting in with the Rotary Club. Like it takes all of these things in order to make it happen. And there's not one playbook for every single one, but we're going to be there at every single one, making sure that they're treating the people of Texas right.
And that's about all the time we have for questions. But I wanted to make sure that we had time to invite our demo groups up today to tell us a little bit about it. So thank you so much, Dr. Towell.